14. A large tank is partially filled with 100 gallons of fluid in which 10 pounds of salt is dissolved. Brine, which is salt water, containing a half pound of salt per gallon is pumped into the tank at the rate of 6 gallons per minute. The well mixed solution is then pumped out at a slower rate of 4 gallons per minute. Find the number of pounds of salt in the tank after 30 minutes. So, we got this tank. We got stuff being pumped into it and pumped out of it. We need to come up with a differential equation that describes what rates of change. That's what derivatives are and what differential equations are. They're just equations of rates, which is what a derivative is. So if you have 10 pounds per gallon, 100 gallons, that's a concentration. If the concentration going in equaled the concentration in here, then and going out, then there would be no change. But we have different concentrations here, and we have different rates of change. So what we want to be able to find is the change in the amount of salt. The concentration of salt is changing per unit time. Okay? So this is rate 1, this is rate 2. So that's going to be equal to rate 1 minus rate 2. Okay? If it's rate 1 minus rate 2 is going to equal the rate of change of this. Okay? So, what's rate 1? They're telling us rate 1 is 1/2 pound of salt per gallon, and it's coming in at a rate of 6 gallons per minute. So what's rate 1? Equals rate 1, which equals what? What's 1/2 pound? So the gallons go away. See how the gallons go away. So now we have pounds of salt per minute, which is a rate of change of the amount of salt. That's what we want. Rate 1. 1/2 pound times 6, that's 3 pounds salt. That's what the S is. Over 1 minute. That's rate 1. And we already know that the rate of change is going to be equal to the rate entering minus the rate leaving. Does that make sense? So here's our this is very important to notice here. That's going to be our differential equation. What's rate 1? Well, rate 2, rate 2. Rate 2 is the amount of salt. We don't know how much salt's in here because everything's changing. We know at times 0 how much salt is in there. There's 10 pounds of salt. But the amount of salt is a function of time. It's going to be changing over the amount of fluid, which is 100 gallons. But is it really 100 gallons? Because this is leaving slower than this is. This is leaving at 4 gallons per minute. This is leaving at 2 gallons per minute. 6 gallons per minute. So there's increasing of plus 2 times the amount of time, gallons per minute. Gallons. There's 100 gallons plus 2 gallons per minute. So 2 gallons per minute. You see that? That this is increasing at a rate of, so the volume and the amount of salt are variable. They change as a function of time. They're dependent on time. You see that? Let me see where we're at on this. Sorry, I apologize. Okay. Because I'm going to have to break these up into a couple videos. So, now we have change in the amount of salt or change in time equals 3. You could drop all the... so this is the amount of salt per gallon times how many gallons per minute? 4 4 gallons per minute, right? So that equals, it's the same thing we did here. This is going to give us pounds per minute. So it's 4 over, factor out the 2, you got 250 plus T. You see? Okay. You could drop all that gallons per minute and stuff like that. So it's 3 minus 4A 250 plus T. Sorry, T. That goes twice. So that equals 3 minus 2A over 50 plus T. See that? Now what? Well, that's a differential equation. Can we separate the variables? No, we can't. So we got to use it, put it into its standard form, which is what? dA dt plus 2A 50 plus T equals 3. Or this, that's your P of T. What's this? That's your F of T, or whatever you want to call it, Q of T, F of T. That's your F of T. See what I did here? Blah, blah, blah. So we need to create an integrating factor. And I'm thinking I'm going to stop right here. Yeah, I'm going to stop here. And then there'll be a part 2.